Okay, this is the last question, and people probably had the most trouble with this one. And then I'm going to go on to the bonus questions. So again, here are your variables, P1, V1, T1, P2, V2, T2. Now, as you're getting more advanced and you practice more, I'm going to start to encourage you to go get what you are solving for first, right? So I found my question word, what? What is the volume of the sample at STP? Okay, so if I'm changing volume, that means I'm probably again solving for volume 2. So this is the one I don't know. Okay, a sample of gas occupies a volume of 50 milliliters. Sorry, guys, in the background, I have videos uploading from previous questions, and I'm clicking on them. Okay, so I've got 50 milliliters. Um, the pressure of the sample is 0.90. Okay, the temperature is 298 Kelvin. Sorry, this is so sloppy. Okay. What is the volume of the sample at STP? So this was a pointer that we talked about in class. Please watch out for this because at STP is a volume and a pressure. It wants you to go to the reference table, which you will be given on the quiz, and get the pressure. So standard pressure is 1 atmosphere, so it has changed. Hasn't changed a lot, but it's changed. Okay, and standard temperature is 273 K, which is 0 degrees Celsius. Okay, and my first temperature was 298 K. So again, it hasn't changed that much, but it has changed. So you have an initial state and a final state. Now we're going to go ahead and write our formula, and we're going to do it every time. That's how you learn your formulas. But it's also a really good exercise for you to make sure that you are substituting in correctly. If you're trying to substitute and you're not looking at the formula while you do it, you're much more likely to put something in the wrong place. And those are simply not the kinds of mistakes you want scientists making. All right. Did I tell you guys about the space? Oh, this is my attention issues. It's really true. We really have to be very, very careful. You know, people who are much, much more sophisticated scientists than I am have lost whole satellites because they screwed up a decimal point in a calculation. This is why we have to be so careful. Okay. All right. Pressure 1, 0.90 atmospheres. I'm going to cut the units out of this one, but just trust me, they're going to cancel. All right. Volume 1, 50 milliliters. All over. Temperature 1, 298. Okay. As soon as you guys started to see this many variables, people started to freak out. And this is why you have to be so careful about keeping track of everything. This makes Mrs. Yowitz happy. Okay. All right. Pressure 2, 1 atmosphere. Volume 2, I don't know. I just don't know. Okay. We're going to solve for it. And temperature 2, 273. Okay. All right. Now, same principles here. You are going to be able to cross multiply. Before you start cross multiplying, you may want to consider, especially since you're restricted to using scientific calculators only in chemistry. You can use a graphing calculator when you're at desk. I just train you on scientific calculators because you're not allowed to use a graphing calculator on the New York State Regents. All right, so this, I'm going to first multiply this part. So I've got 0.90 times 50 is 45 over 298. So I'm just going to replace that with 45. Okay, so that when I start cross multiplying, this all makes sense. All right, so to make my life a little bit easier, I'm going to do this in order and I'm going to keep it in order. And I'm going to make a decision about what order I want to do. Where do I want my X to be? Okay. Some people are okay with their X being on the left, on the right. I don't know. Personally, I don't really love it. I kind of want it to be on the left for some reason. If you would like it to be if you're comfortable leaving it where it is, that's fine too. All right, so if I go this way to keep my x on my left-hand side, I'm going to get 298 times 1 times my v2, which is my x. So that's basically just 298 times v2, right? Because this is times 1, and everything times 1 is itself. So now I'm going to go ahead and do my multiplication in the other direction. I'm going to do 45. Let's do that in a different color. And do 45 times 273. Do you see how I systematically wrote my equal signs so that I knew I was writing a real algebraic equality and I could keep track of what was happening? Okay. And on the second one is going to be 45 times 273. I'm just going to I don't think that shows up on the screen. I'm going to do 45 times 273, 12,285. Okay, now I want V2 by itself, so I'm going to divide both sides by 298, which I'm really happy about because that was an enormous number. I kind of want to get rid of it. V2 is now equal to 12,285 divided by 298, and everybody should have gotten 41.22 milliliters. Okay, and I'm keeping track of my units by looking at what my original unit was, but you really should be very careful because you have to make sure sometimes all your units are lining up and stuff. All right, that was that question. Let's move on to the bonus questions, you guys.